next we are having a sp3d hybridization. The sp3d hybridization, and the name itself says that here during the hybridization the 1s, 3p and 1d orbital undergoes mixing and recasting process, and total since 5 orbitals are getting into the mixing and recasting process, so the 5 new orbitals will form, and those 5 new orbitals are called as sp3d hybrid orbitals. So sp3d hybrid orbitals, 1s as I said, the 3p orbital and the 1d orbital undergoes mixing and recasting, and 5 new sp3d orbitals are formed. This sp3d hybrid orbital. The example for this, I can say the formation of PCl5 molecule. The PCl5 molecule, phosphorus pentachloride, the structure of PCl5 can be explained only on the basis of sp3d hybridization. Now let's see PCl5 structure. The phosphorus here, whose atomic number is 15, its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p3. So I'm just writing the outermost shell configuration, that is 3s2 and 3p3. Because already while talking about the hybridization and all, we don't ever consider the electron from the inner shell. So 1s2, 2s2, 2p6 is there, but I had not written here. So it's a 3s2, 3p3. So 3s2, 3p3 means s will have 2 electrons, the p will have 3 electrons. Total half-filled orbital is 3, but phosphorus is forming a 5 bonds. It means there is a 3d orbital also. See, after 3p generally the 4s comes, but here I can say during the excitation the electron cannot create a new shells. So it will jump to the higher energy level of the same shell only. That means we'll jump to 3d. So 3d which have 5 orbitals here, 1, 2, 3, 4, 5. Okay, then phosphorus. This is in excited state now. Now in excited state what will happen? The configuration will changes to 3s1, the from completely filled will jump to the empty orbital, and then 3p3, and then we will have 3d1 configuration. So 1 electron in s, 1 in p, 3 in p orbital and 1 in d orbital. So finally the phosphorus undergoes sp3d hybridization. We are saying it's sp3d hybridization because all 1s orbital, 3p and 1d orbital. So 1 electron distribution will be same. So we are having overall 5 orbitals which from the 5 orbitals in a phosphorus, in the outermost shell of the phosphorus. Now PCl5, chlorine whose atomic number is 17, so it's a like outermost shell configuration. I'm just writing, it's a 3s2, 3p5. S will have 2 electron and P will have 5 electrons. So this is not P. So 1, 2, first singly and then pairing will take place. Okay. So from P chlorine I can say this PZ orbital will come, and from phosphorus all 5 orbitals will come. Let's see the geometry of the PCl5 molecule. In PCl5 molecule the phosphorus atom is at the center. Now since here the d orbital is taking part in the bonding, that is overlapping, and d orbitals are considered as a little complex orbital, so here you are not expected to draw the geometry and all. Here we are having only we are not having a overlapping of the d orbital in a since the d orbitals are involved, so overlapping is not expected. So here we have only the geometry, how PCl5 is oriented, that is all chlorine atom. So in PCl5 molecule, this is phosphorus at the center. 1 chlorine is here, 1 chlorine is here, 1 chlorine is here. These are the 3 chlorine which is belonging to the same plane. So this is trigonal planar geometry I can say, because these 3 chlorine is in the same plane. There are 2 more chlorine. The 1 chlorine is here and 1 chlorine is here, and these 2 chlorines are perpendicular to the plane. Perpendicular to the plane means how it is. Now see, this means suppose if this is a board, 1 chlorine will be here, 1 chlorine will be here, 1 chlorine will be here, and that chlorine, this chlorine which we are having, it is perpendicular, means this is the phosphorus of this chlorine is here, that is perpendicular to the plane, and this chlorine is behind the board, that is towards your side, again perpendicular to the board. So I can say that since they are trigonal planar, so this angle is 120 degree, but since it is a perpendicular like something like this, so it is 90 degree. So in this case, here we have the two types of CL-PCl bond. The one CL-PCl bond is 90 degree, which are perpendicular, and the CL-PCl bond is 120 degree. The axial CL-PL, this is axial chlorine, and this is equatorial chlorine. Equatorial chlorine is forming 120 degree angle, and axial chlorine is forming 90 degree angle. Now in the case of this PCl5, this geometry is called as trigonal bipyramidal geometry. Why trigonal bipyramidal geometry? Because this chlorine is trigonal base, and this chlorine is getting on the surface, means here. And if I am joining all three chlorine, when these three chlorines are joined, you will get a pyramid on this side, and similarly the same thing when the chlorine is present on opposite side. That is, two pyramids will be obtained. So the geometry is trigonal bipyramidal. Okay, now let's see in that animation. In animation, you can see that we have the geometry of the same PCl5 molecule, where the three chlorine, this is the phosphorus at the center, these three chlorine atoms are present in a plane, and here we have the two chlorine atoms which are perpendicular to the plane. The chlorine atom which is perpendicular to the plane is forming the 90 degree angle, while the chlorine atom which is present in on the equatorial position, they are forming 120 degree. And this geometry is called as a trigonal pyramidal, because when these three, the equatorial chlorine atoms are joined with the axial chlorine, we get pyramids on the one on the upper side and the one on the lower side. And hence PCl5 is having called that it is having trigonal bipyramidal geometry.